Hello everyone, this is Swati from Aeronautical Engineering. We had a assignment called Complex Engineering Problem Project. We had a topic got torsion test on steel tube. Me and my friend Tejashwini, we both are on this project. So let's begin this. Introduction to torsion test. Torsion test is a key mechanical test used to analyze how materials respond when subjected to twisting force. This test is particularly important for components like shafts, structural beams, and tubes, which may experience torsional stress in real-world application. When a steel tube undergoes a torsion test, it is subjected to a torque cause it to twist and deform. The test helps to evaluate the shear modulus, yield strength, ultimate shear strength, and fractures characteristics of the material. This information is crucial for ensuring the safety and durability of steel tubes in various engineering applications. Next, importance of torsion test. The torsion test plays a significant role in material testing because it helps engineers assess the performance of materials such as steel tubes under rotational stress in real world applications. Structural components like shafts or pipes are frequently exposed to twisting or rotating forces. Understanding how steel tubes react to these forces allows engineers to select the right material for specific application. It also helps to predict potential failure modes, ensuring the design of components that can withstand the instead loads without premature failure. The result of torsion tests are essential for material selections, product designs, and safety standards. Next, torsion test setup and equipment. The setup for a torsion test typically involves a specialized testing machine designed to apply torque to the steel tube. The tube is securely clamped to both ends, with one end fixed and the other twisted using a motorized mechanism. The amount of torque applied is measured using a torque sensor, and the angular displacement, which is known as twist, is tracked using angular displacement sensors or optical method. Strain gauge are often placed on the surface of the steel tube to measure strain during the test. The machine records real-time data, enabling engineers to analyze the material's behavior under applied torsion. The next one, mechanical properties measured in torsion. The torsion test provides valuable data on several key mechanical properties of the steel tube. One of the most important properties is the shear modulus, which indicates how resistant the material is to shearing forces. The test also determines the yield strength of the material, the point at which permanent plastic deformation begins. Additional, the ultimate shear stress and shear strength is identified, which represents the maximum shear stress the material can endure before it fails. The test also helps to assess the material's ductility by measuring the total angular displacement before fractures. Next, shear strain. Shear strain behavior during torsion. This strain stress behavior of material under torsion is essential for understanding its deformation characteristics. It's essentially as torque is applied, the material deforms elastically with a linear relationship between shear and strain stress. The elastic region is governed by Hooke's law, where the shear stress is proportional to the strain. As the stress increases, the exceed the yield strength, the material enters the plastic deformation region. In the stage, the stress strain curve becomes non-linear. The ability to qualify this relationship is crucial for assigning the material's performance in real-world application and designing reliable components. Shear modulus and its significance. Shear modulus, also known as the modulus of rigidity, is one of the key properties derived from torsion testing. It represents the material's resistance to shearing deformation when subjected to a twisting force. The shear modulus can be determined from the initial slope of the torque versus angular displacement curve. Steel, which has a relative high shear modulus resistance, torsional deformation more efficiently compared to other material. In application when torsion stiffness is important, such is in staff or structural beam, material with a high shear modulus like steel are performed. This property is critically consideration in engineering designs. Seventh one, yield strength and plastic deformation. The yield strength is a critical parameter in torsion testing as it marks the point at which the material begins to undergo permanent deformation. Below this threshold, the material returns to its original shape once the applied torque is removed, indicating elastic deformation. However, the material reaches its yield strength to enter the plastic deformation zone where permanent change in shape occurs. For steel tubes, understanding the yield strength is crucial for determining the maximum twisting force the material can endure without permanently distorting, which is essential for designing components subject to rotational stress. So next, ultimate shear strength. The ultimate shear strength represents the maximum shear strength the material can withstand before failure. In the torsion test, after the yield point, the material continues to deform plastically until it reaches the ultimate shear strength, which corresponds to the highest point on the strain stress curve. Beyond this point, the material can experience necking, where the tube experiences localized deformation leading to fractures. By understanding the ultimate shear strength of a material, engineers can design steel tubes and other structural components that can safely handle torsion load during operations. So the next, angle of twist and deformation. The angle of twist and deformation is essential parameter measured during a torsion test. It represents the angular displacement that occurs in the steel tube as the result of the applied torque. The relationship between torque and the angle of twist is linear in the elastic region, but it becomes non-linear as the material yield and undergoes plastic deformation. The total angle of twist before failure provides insight into the material's ductility and ability to absorb energy before fracturing. For steel tubes, a large angle of twist before fracture indicators good ductility, which is often desired to many engineers application to prevent brittle failure. Next, failure modes in torsion test. In torsion test, several failure modes can occur depending on the material's properties and the test conditions. One common failure mode is shear fracture, where the steel tube breaks along a plane of maximum shear stress. Another failure mode is excessive plastic deformation, where the tubes twist significantly but does not fracture. In some cases, the tube may undergo a combination of both failure modes. The way a material fails under torsion provides valuable information about its toughness, ductility, and resistance of fracture, helping engineers design safer and more durable components for torsional applications. So next, fatigue and test under torsion. It is assigning the behavior of steel tubes under cyclic torsion loading, which is common in many applications such as automotive, dive shaft, or machinery parts. In test, the steel tube is subjected to repeated twisting. The number of cycles the materials can endure before failure. Engineers can evaluate its fatigue resistance. The result of fatigue torsion test helps in designing components that are resistant to failure due to cyclic loading, ensuring their reliability in dynamic application. Temperature effect on torsion test. Temperature plays a significant role in the torsion behavior of materials. As the temperature increases, steel generally becomes more ductility, allowing it to undergo more plastic deformation before failure. However, at lower temperature, steel becomes more brittle, which reduces ductility and increases the sustainability to fractures. In torsion test, temperature control environment are used to study the material's behavior under various thermal conditions. Understanding how temperature affects the torsion test result is vital for application exposed to extreme temperatures such as aerospace and cryogenic environment, where components may be subject to high or low temperature during operations. Strain measurement techniques. In torsion test, accurate measurement of strain is critical to understand the material deformation characteristics. Strain gauge are oftenly applied to the surface of the steel tube to monitor the strain. As torque is applied, this gauge measures the elongation of compression of the material at specific points, allowing engineers to calculate the shear stress at different stages of the test. Additionally, optical method such as digital image coloration DIC can be used to capture the fulfilled strain distribution across the tube's surface, providing a more comprehensive view of the material's deformation behavior during torsion. So next, data acquisition and analysis. In this system are these systems are essentially in torsion testing, as they record the torque and angular displacement throughout the test. This data is used to calculate the shear stress and strain, which are plotted to form the stress strain curve. Advanced software is often employed to process and analyze the data, allowing engineers to determine key mechanical properties such as shear modulus, yield strength, and ultimate shear strength. Post-test analysis also includes assigning the fractures surface to determine the failure mode and to form and to gain the further insight into the material's performance under torsional loading. Okay, compression with tensile and compression test. The torsion test provides unique insights into material properties that are not fully captured by tensile or compressive test. While tensile test accesses a material response to pulling forces, and compression test evaluate it before under sneezing and squeezing force. Torsion test focus on how material behave under twisting forces. The combination of result from tensile, compressed, and torsion test offers a comprehensive understanding of material mechanical properties, ensuring that engineers can design components that perform well under various loading conditions. For steel tubes, a balanced understanding of all these properties is crucial for performance and safety. Steel tubes and engineering applications. Steel tubes are widely used in a variety of engineering applications where strength and resistance to torsion force are crucial. In automotive industries, steel tubes are commonly found in drive shafts and suspension components, which experience significant torsional stress during operations. In constructions, steel tubes are used to structural framework and support under real world conditions. Next, applications in automotive engineering. In automotive engineering, steel tubes are extensively used in the part of such as drive shafts, suspension links, in chassis components. All of this are subjected to tensile forces during operation. Tensile test on steel tubes helps determine and the material sustainability. For this application, draft drive shafts, for example, need to resistant torsion without excessive deformation to transmit power from the engine. to the wheel effectively through torsion test. Engineers can ensure that the steel tubes used in a such components have the right balance of strength, ductility, and fatigue resistance to perform safely and efficiently over time. So next, aerospace industry and torsion testing. In the aerospace industry, steel tubes and other structural components are subjected to complex loading conditions, including torsion. Torsion test is critical for ensuring the safety and performance of aerospace structures, such as wings and control surface. Steel tubes used in this application must be able to resist twisting force while maintaining the integrity over a wide range of temperature and loading condition. Torsion test in aerospace applications are often conducted at elevated temperature to stimulate high attitude conditions, providing valuable data to prevent structural failure in critical parts of aircrafts. So next, construction industry used to steel tubes. Okay, steel tubes are commonly used in the construction industry, particularly in the form of steel columns, beams, and other load bearing structures. These components are often subjected to bending, shear, and torsional forces, especially in earthquake resistance buildings or high rise constructions. Torsion test is essential for assigning the shear strength and rigidity to a steel tube used in such application. Engineers are torsion test results to optimize design, ensuring that the steel tubes can withstand the torsional force encountered during events like earthquake or high winds without failing or extensive deformation. So next, design consideration based on torsion test result. The result from torsion testing help engineers to make critical design decision for steel tubes used in shaft beams or other components. Engineer must ensure that the materials has an adaptive shear modulus and yield strength or to withstand the expected torsion stress. Additionally, the inductility, ultimate shear strength of the material, is considered to be avoid brittle frames, extending the lifespan of the service. So next, challenges in torsion test. Torsion test can be challenging, particularly when walled steel tubes or tubes with irregular geometry. Ensuring that the applied torsion are distributed evenly across the length of the tube can be difficult, and localized stress constructions can lead to the inaccurate result. And the technologies continue to improve the accuracy. Advanced torsion testing techniques. In recent years, advanced torsion techniques have been developed to improve the precision and efficiency to test. For example, digital image correlation (DIC) systems allow to fulfill field strain measurement, capturing the material's deformation across the entire surfaces, detailed data, and enhance the ability to evaluate whether materials performing under torsion is more effective. Okay, effects of manufacturing processes and torsion properties. So next, torsion testing in research and developments. Role of torsion test in safety standards. Impact of material components on torsion test results. So long-term durability and torsion testing. Simulation of real-world condition in torsion testing, and evolution of torsion testing techniques. The techniques used to torsion testing have evolved significantly over years of something. Then how understanding of how materials like steel tubes perform and under complex loading, and enhancing the reliability and engineering designs. At last, the conclusion. In conclusion, torsion testing on steel tubes is a critical process of evaluating the material's performance under twisting force by providing detailed information. Industries, mainly it is focused on the industries called automotive, aerospace, and construction as test technology, having many of these industries, and continues to evolve, offering more accurate data and support the development of this ensure reliability of structural components undergo torsion. So thank you.